In this part of video, we will see what a statistical model in general is. Statistical model is a set of mathematical equations and assumptions that describe the real-world situation. When we are building a statistical model, we are trying to explain the data through some mathematical equations and some assumptions. To understand this better, let's apply this definition to simple linear regression. We have straight line equation in simple linear regression, which forms mathematical part of statistical model, and there are some assumptions. Here, assumptions mean the dataset is expected to fulfill certain conditions so that simple linear regression can be applied to that dataset. We will see these assumptions in more detail in upcoming videos, but here I will explain one assumption so that you will get an idea what an assumption is. When you plot the data in a scatter plot, data points should resemble a straight line pattern. This is one expectation or assumption about the dataset in order for us to apply simple linear regression to that dataset. If the scatter plot is resembling a parabola or a shape of a circle instead of a straight line, we cannot apply linear regression. In that situation, we have to look for some other statistical model. So, in summary, a statistical model is set of mathematical equations and assumptions. The purpose of statistical model is to explain the real-world situation with minimum errors. The statistical model breaks down the data into non-random or systematic component which can be described by mathematical equations and a purely random component which are called errors. For example, when the data is fitted to a straight line, systematic component is explained by straight line equation y equal to b0 plus b1x, leaving out the random errors. Straight line equation and errors together explain the real world situation. As we have seen in our case study, we derived a straight line equation which minimizes errors. So, simple linear regression is an example of statistical model where data is represented by a straight line equation which is systematic component plus errors. And these errors are purely random. We say random because they cannot be predicted. We don't know why some data point is far away and some other is near to straight line. There will be always some random component in statistical model. In the end, the aim of any statistical model is to bring out all systematic components, leaving out only random errors. Here, systematic components can be patterns, repetitions, which can be represented by mathematical equations. See this example. At first glance, we might think that dots are following a straight line. But if we observe carefully, we can see that there is one more pattern. After every 4 data points, the graph is repeating itself like a cycle. So, to explain this pattern as a whole, along with a straight line, we need some more mathematical equations so that we can explain all the systematic components. Here, systematic components also include the repetition for every 4 data points. This repetition should also be represented by mathematical equation. This particular example represents a time series, which is a statistical model just like simple linear regression. In this example of time series, graph is repeating itself after every 4 months or 4 years depending on the time scale with an upward trend. We use more complex mathematical equations to explain systematic components in this kind of scenarios. So once we have all systematic components in the form of mathematical equations, the only thing that is unexplained in the data is randomness. The amount of randomness in the data determines if any statistical model can be used for predictions or not. If the model is having too much randomness and less systematic component, the predictions will be far from reality. This is where statistical tests become useful. To know whether a statistical model has enough systematic component so that we can rely on that model to make predictions, we make use of statistical tests. For simple linear regression, we use hypothesis test and ANOVA test. We will see in upcoming videos how to conduct these tests. Now let's see one important characteristic of a good statistical model. A good statistical model should be parsimonious, which means a model that uses the minimum number or just the right number of variables to explain a real-world situation. In our case study, we used only 2 variables. But statistical models can be built using much more than 2 variables, which can run into tens or even hundreds of variables. In these scenarios where there are numerous variables, we should try to build a model using only those variables which have impact on the real world situation. We should try to eliminate variables that have no effect. But how can you decide which variable to include in the model? One way is through having good knowledge or understanding of the business from where the data is collected. If you are not familiar with business, we can approach experts who have deep knowledge about that business domain. The other way is to eliminate variables from the model using statistical tests. We will see these tests when we work with models where there are more than one variables involved. Next, the purpose of statistical model. The purpose of any statistical model is to explain the relationship between variables and predict the probable values of variables. That is the ultimate aim of any statistical model. There are various types of statistical models and simple linear regression is one of them. While statistical models are very useful in explaining the relationships and making predictions, there is one important thing that we have to remember. No model is 100% accurate. It's only approximation to closest mathematical model. Essentially, all models are wrong, but some are useful. With that note, we close this session. See you next video.